So let's continue. Next talk is what's new in C and POSIX standards, presented by Peter Zentraut. Peter is a long Postgres hacker working on Postgres features and also related projects. He's been a committer since 1999, I think. So, stage is all yours, Peter.
Thank you. All right, I'm going to try to hold this microphone like this. If there's any audio problem or I have to speak up, please let me know. Okay, so this presentation is a culmination of several deep rabbit holes I've fallen into over the last few years while hacking on Postgres code and trying to understand certain things. And so I figured it's occasionally nice to, sort of look at these technologies that we're building on and investigate how they work instead of maybe just taking them as given. So I'm going to do a little bit of context and background on these two standards, and then I'm going to go through this is just the way it worked out. I'm going to talk about the last two standards in each case. The first one the older one of which is sort of the one that would be the next threshold for Postgres code, right? And then the other one is the brand new one, or was at least brand new when I wrote this talk proposal. Okay, so to clarify, what is even the difference between these two things? C is, of course, a programming language, has a compiler and a C library. The C library is actually quite limited for doing real programming, at least the kind of things that we want to do. So that's where POSIX comes in. POSIX is essentially an attempt to standardize what a Unix-like system is. And just trademark issues, so you can't call it Unix, but that's sort of the idea. So it is effectively, and some of these things go back to the 1990s, 1980s, and it used to be different things. But as of now, it is essentially an extended C library and then all the shell stuff, right? The actual shell and grep, set, awk, and all that kind of stuff. That part we're not going to talk about. So for our purposes, it's essentially an extended C library. And of course, most of the operating systems that Postgres supports are POSIX aligned operating systems, except Windows. So on Windows, you generally can't use any of that. And that's the whole problem with porting to Unix, to Windows. Right? The C library is the same, hopefully, but the POSIX library is generally not there, or only small pieces. And then another thing you might have heard of is the single Unix specification, which is another standard that comes from another industry consortium related to Unix. And that is, again, used to mean many different things in the past, but as of now, it's essentially a slightly extended version of POSIX and then plus curses. We're not using curses in Postgres, right? So it's essentially almost identical to POSIX. So you might sometimes see this in old discussions or commit messages of like POSIX this, SUS that. They're essentially the same, right? So, but they're sort of concentric circles in a way, right, of adding more stuff. So just as an idea of what's in these things, right, there's obviously long lists and stuff like that, but just so as an idea, the C library, for example, has the file type I/O, and then POSIX has file descriptor I/O, right? That's sort of the Unix thing, and then various other differences. In C, you can set locale, but you can't really do much with that. You just set it, and the program behaves in a certain way. In POSIX, you have a bunch of other things like use locale, NL lang info, and things like that. Interesting, perhaps, is in the C library you have getenv to get an environment variable, but there's no setenv. But in POSIX there's setenv, and various other things here. So it's also in the right column you see what the XSI option is that essentially defines the single Unix standard. It's fairly obscure stuff, right? So that difference is not that useful. A couple of things here, I don't know if you can see this, I put them in gray here, but stirred-up, for example, and Strudland, they're in the POSIX column, but they have actually sort of migrated over to the C library in recent versions, so some of that stuff also sort of migrates between columns sometimes. Another example of how these standards differ or refine each other. In standard C, for example, all these integer types that we're now using, like int 32t, int 64t, they're actually all optional. You don't have to provide that because in the C implementation, you're not required to have 16-bit types. You could have a 10-bit type and a 20-bit type, for example. And so you don't have to have those types. But in POSIX, that's required. You have to have an 8-bit type, 16-bit type, and so on. So, you know, the actual sort of core C is very liberal of what you could do. So POSIX kind of clarifies that and makes it a little bit more practical. Also, I found this interesting that the int pointer T and new int pointer T that Postgres uses without any checking, they're actually not even part of POSIX or not required by POSIX. You have to have this even like this additional layer. So. Another, again, sort of how POSIX makes C better, you could say. In standard C, to write a null pointer constant, you could either write digit 0 just by itself, or you can have digit 0 cast to void star. Those are two ways of writing null pointer constant. And then the macro null that everybody uses is defined to one of those two. But it could be either one, right? So you could have defined null 0, like this. Like you could do that, that's valid C, but that's very dangerous. If you have functions without prototypes or variadic functions which don't have prototypes for the variadic arguments, then the compiler doesn't know if you're passing a pointer or an integer. And if the integers are 32-bit, pointer 64-bit, which is common, then it'll crash. So that's very bad. And so you sometimes see this in old code or code that's trying to be really portable, that all the occurrences of null are cast to a pointer in a pointer type to avoid that kind of thing. But in POSIX, you don't need to do that. In POSIX, it's required to be void star 0. And additionally, POSIX requires that if you memset a pointer to all 0, then it's also a null pointer, which C doesn't require. But Postgres code obviously very liberally relies on that. So, right. So things like that, right? So where does C come from nowadays? It's a ISO standard made by this working group there, DGC1, SC22, WG14. If you've seen some of my talks on the way the SQL standard works, it's very similar to that, right? SQL standard is SC32, WG3. So, you know, it's the same similar thing in a different part of the hierarchy. SC22 is programming languages, so there's other working groups. For example, working group 21 is C++, and so on. So there's a website. This is quite, I'll show it really quickly. Let's see if this works. Because this is possibly useful. So this website looks very basic, but it is up to date. You can see the data up there or not. It's, you know, it's updated recently. If you just do a web search for WG14, you'll find this. But the interesting thing is you can read up all the meetings and everything here. But if you go to projects, you can look at the standard, right? You can go to ISO and buy it, or you can just look at the drafts that is similar, if not identical, and then you just look at it. So you can, you know, it's right there. So if you ever want to read the C standard, if you weren't able to find it, it's there, right? Go ahead. So just a note on that. So I did a field trip in preparation for this talk. I went to one of their meetings. This is what that looks like. So this was in February. Yeah, so, you know, it's approachable. You can go there. And there are C programming language nerds there, so it's quite interesting. And POSIX situation is different. POSIX itself is an IEEE standard. I have not dug into how IEEE standardization works, but the actual POSIX standard is sort of a custom model that the IEEE and the Open Group. The Open Group is the industry consortium that does the single Unix standard. So they are collaborating under a sort of a custom setup called the Austin Group. That's just because they met in Austin the first time, and they are developing the standard, and then when they're done, they're passing it off to the IEEE and the Open Group, and then also ISO, and they just put their stamp on it. So they also have a website. It's also so very basic, but you can also find the information there and sign up to their mailing list and all that kind of stuff. So I don't have field trip photos, but in lieu of that, Thomas Munro here has been trying to fight the good fight here and send them some email messages to try to get some things changed. So it is also possible to, have you succeeded in anything yet? Limited, okay. Yeah, but it is work, right? But my point is it's relatively open and you can just go there and participate, and all the usual suspects from all the various C libraries hang out there and you can try to make things happen. So these are the C versions in existence. The 89 is what people used to call ANSI C. That was sort of the first one that was standardized that most people used for the longest time. I didn't even know that was in 95, but it is listed. C99 is what Postgres uses now, of course, and then the next one would be C11. C17 is essentially just a bug fix release on C11, so it doesn't have any new features, so it doesn't really make a difference also which one you use, but it is a distinct version. And then the C23 was published in 2024. So there are a couple of off by one errors here, as you can see, but that's correct because the working group basically says in 23 we're done, sends it to ISO. ISO looks at it for 6 months, and then they publish it in 2024, and then that's how it's called. But these are the correct numbers, right? There is no C24, right? Some people might say that, but that's incorrect. So this is correct. On the POSIX side, because of all these different bodies involved, it's more complicated, but what I want to give you is basically the first column is the most important one. They're in the Austin Group era, I would say. There's 3 versions, 2001, 8, and 24. And then there's various core agenda versions in between. Some people, there's also, sometimes you see POSIX 2017 written about, but that's essentially just a bug fix on 2008. It doesn't have any new features. And then so the IEEE has their versions. Again, they pass it to ISO. ISO publishes it. The Open Group has their own releases of that. And then there's a single Unix standard version, which I don't know why they're different from the Open Group issue versions, but who knows. And then also, if you get single Unix standard certification, you can then use the Unix trademark for your product. So that is the last column. So there are actually still some products that are certified and can call themselves a Unix. So for later, when we put the slides up, I put the links down there, how you can actually read the POSIX versions. The way you would normally do is you go to the Austin Group website, sign up for an account, and then they'll give you the link, but these links are on the public internet, so I'll just, you can look at them later and bookmark them. Or you can also just do web searches of, I sometimes do like Open Group, sprintf, and then it'll get you to that kind of site. So again, this is, you can also read this in public. Okay, so now let's talk about what's new in POSIX 2008. The one big one for us, I sort of realized retroactively, is that all these locale functionalities, the locale handles like locale T and all the _L functions, they were standardized in 2008. And there's different ways of talking about it. In Postgres, we obviously use this as sort of per column locales or whatever you want to do, right? But it was also initially talked about as sort of per thread locales, for example, right? So because initially you could only do one locale per process, and if you want to do threads and want to have multiple locales in play, you need some kind of API like that, right? So that's actually required by Postgres as of Postgres 17 already. So we are effectively requiring this now already. There's also a couple other functions that we're already using. For example, strulen is used in Postgres. We have a configure check for that, which we could probably remove because it should be supported by everything now. Everything below the line is not supported by Windows, so that's just a nice thing we can't have. Everything above the line is supported by Windows. So one interesting, there's a long list, right? But one interesting I want to maybe as an example is these add functions here. They look like regular file system access functions with an @ and the way these work is they have an additional argument, which is a file handle for a directory that you've opened, and then all the relative paths are resolved relative to that directory. And so you can use this in multiple ways. You can make, if you scan through a directory, you can make that safe against races if someone else names things at the same time. You could also use it, for example, to have a sort of a per thread current directory in a way, right? So it's kind of a theme here, right? Thread support. Yeah, but I tried to see if you could emulate this on Windows somehow. It doesn't seem possible. So yeah, there's lots of stuff we probably won't be able to use. Yeah, so that's the effective standard by Postgres right now. A lot of stuff not available in Windows. That's just the life, right? So let's look at POSIX 2024. So if you look at the list of what's new, you'll first of all find all the C17 library functions. So the baseline has been lifted from C99 to C17. So all of that is included. One thing we're already using is getText. getText is now standardized. That was surprising to me. So all the ones with the marks here is what Postgres is already using. And then just some random other stuff we're already using. People we're using, that's standardized now. Strillcat and Strillcopy we're using, that's a long time in use. Came from OpenBSD, that's standardized now. There's a new function called qsortr, which is the same thing as qsortarg in Postgres. Trick there is different operating systems have implemented qsortr with different argument orders. And then the standard decided on one of them. So if you go to, and the victim in that case was FreeBSD, they had to change theirs. So there's a different argument order in qsortr between, I'm going to say, FreeBSD 13 and 14 or something like that. So it's a bit. There's a comment somewhere in the Postgres source code that we should use memmem here if it were available. So it is available now. And the get locale name L it gets you the locale name for a locale handle. I wrote an email to hackers some months ago, said there really should be a function to get the locale name for a locale handle, but there doesn't seem to be one. And then, a couple of weeks later, I worked on this presentation and said, oh, there is one. That's good. But it doesn't appear to be implemented anywhere yet, so it doesn't actually seem to exist. So, but that, that could be. It would be nice. So a couple of useful things here. Don't want to go through all of these, but just sort of as an example of the kind of things that is being worked on, the first function there, POSIX close, is like close, just close the file handle, but it tries to deal with the following problem. If you close a file handle and that gets interrupted by a signal, what happens? And in POSIX 2008, it was basically said, well, you could get an error, so the error no and then error return. But then it is unspecified what happened to the file handle. It could still be open or it could be closed. And to do this technically, well, there is basically no way to do this correctly because you could say, well, then I'm just going to loop until it works. But again, if you have a multi-threaded application, it could be that by the time you loop around, another thread has already allocated that file handle. And so that was basically just impossible to do correctly. And so this has been fixed now. I'm just going to, if you're interested in details of that, just look up the man page for POSIX close. It's just an interesting tale. As far as I can tell, no operating system that Postgres supports is actually affected by this, so this is more sort of theoretical amusement. But those are the kind of things. I think, again, there's sort of a theme, plugging holes created by threads and concurrency. It's definitely a theme here. There's also a couple things that were removed. The ones here with the red X, these are actually in use by Postgres code, so there might be a small little project, someone go through and replace those with the designated replacements. All right. So yeah, so this 2024, there's not sort of huge features, but it is a long list of sort of existing practices and existing functions being standardized and bugs fixed. I haven't seen any movement really in the implementations. So for example, in glibc, git master, there's like nothing really in there. So this might still take a while until it becomes, or somebody says, we're claiming conformance to this now, right? Obviously, a lot of these bits and pieces are already available here and there, so you can just do configure tests and use them. Okay, so this is about POSIX, and let's move to C. So I picked out sort of things that would be interesting for Postgres code, and I'll have more examples here for the things that have arrows. A couple of things that, and then there's other things that are not that applicable to Postgres code. For example, there's lots of details about floating point support, complex number support. That's obviously very important to certain types of application, not so much for Postgres. So I'm going to just skip over that. So I'll show some examples of how you can use some of these features in Postgres code. Before I get into this, a note about how sort of the keyword evolution in C is handled. So if you want a new feature, sometimes you need a new keyword, right? If you just add a new keyword that's bad, could collide with existing code. So the idea is then you use a keyword that doesn't collide, and so there's a kind of a reserved namespace of underscore capital letter something. So that then you don't have name collision, but looks ugly, right? So the actual solution in practice is the actual keyword used by the compiler is underscore capital letter something, and then there's a macro defined in a header file for the lowercase name. So this is a little pattern you'll see. And this is not new necessarily here. The bool type in C99 worked exactly the same way. Right? So just remember when I show you these examples, that's actually what's happening underneath. So here's an example of that. So there's a new operator or thing, construct, get the alignment of a type. Right? So again, this is actually underscore capital A align of, and then you have the header file, and you can get the alignments. Could be useful, right? Then you don't have to write all these configure checks to get the alignment. You can just ask the compiler directly. I'm also putting notes here. Many of these things are also existing in C++ that could be of interest if you want to adopt this and you want to put it in a header file that you also want to use with C++, which Postgres tries to do. So that's why that is there. Okay, so this could replace a configure check. That's maybe okay. The other one is, so the previous one was align off. This is align as. This actually tells you how to align a thing. And that's obviously something that Postgres cares quite a bit about. So here's an example of how you could use this in an actual piece of code that I tried to change. So normally you do this with the union, right? You just have some kind of buffer, and then if you want to align it, you stick another member in the union. And so instead of doing these kind of tricks, you can just write it like that now and tell it to just align it this way. So this is code beautification, perhaps. This is a thing that you can't really write in a portable way until now. If you want to align something to, because if you want to do the union trick, you need another type that has the alignment. But if you want to align something to like a larger block, you need to use something non-standard. I mean, most compilers have some kind of attributes like that, but this is sort of the code we have up there. It's like, use this attributes thingy that is defined elsewhere, and just for good measure, throw in a couple other things into the union just so we get a little bit of alignment if we don't have that. And later on, there's also other code, and if we don't actually have the attribute, then we have to disable direct IO and all kinds of things. So you can just write it like that now, and it's pretty clear.
So that's just a number, and then you can align it?
Yeah, in that case, it's a number. Yeah. You can also put a type in there, and it just takes the alignment of a type. But in this case, this is a number that's defined somewhere else, right? It's like 1K, or there are a couple different versions of that, right? So I think this could be useful for things people are currently working on. Okay, so this is a small thing that is already effectively in use in Postgres code to designate that a function doesn't return. So this just gives better compiler diagnostics. The problem with that is that the current GCC, for example, has its own syntax for that, which is underscore attribute no return, which you can use. But remember then, if you include this header file, this is actually underscore capital N no return, and then GCC is not going to recognize that anymore. So you can kind of trip your own foot or something like that. So for that reason, in Postgres 18, we've actually defined this as PG underscore no return, and so this is actually in the code right now. This is not in C++, but we'll see later about a way to do that in C++ as well. Static assert we're using Postgres as well. This, there's a whole long page of workarounds and variants of this. Maybe this could be simplified by just using that. One thing to note, and there's been confusion historically either by users or by implementations. So static assertion in C terms is a declaration, it's not a statement. That means you can put it where a declaration would be allowed. For example, you can put it at file scope. This seems to be some parts of Postgres code that try really hard not to put assertions at file scope and just put it somewhere else with a comment, well, it would be nice if you could put it in file scope. You actually can put it there, it's just fine. The flip side of that is because Postgres has this warning option of you have to put all the declarations before statements in a block, right? That also then affects that. That's just what you get with that. So just in case you're surprised by that. Okay. This is the thing that a lot of people trip over regularly. In versions before C11, you can't redefine a type. You just get I guess in this case, you get a warning. This is GCC. In C11, that's allowed. You can just redefine a type to the same thing. Right? So if you just do this and you do it again, that's fine. If you do it to something else, obviously that's an error. So this is, a lot of people want to do this, or at least the recent work where people tripped over this is to make header files less dependent on each other. So you don't have to include the header file in the other header file, you just define the type over there that you want. And then that's an incomplete struct, which will then get resolved later. So that's fine. I think that a lot of people would probably like to use this. Okay. Oh no, this doesn't work. Anonymous structs and unions. So again, I'm trying to use sort of an existing piece of code here. This is kind of actually a thing I tripped over some years ago. You see this a lot in Postgres. You have a struct and then another struct in it, or unions inside the struct. And in this case, you don't actually have to give it a name. You can just use the fields directly. So that would be an anonymous union. It's sort of a simplification. It's cosmetic in a sense, right? But this actually is quite common. And then usually you have some stupid name here like info or you or something. So people said well, this isn't that worth having a name, but I have to put one here. So people have thought about that. So anonymous unions exist in C++ as well, but anonymous structures don't exist in C++, which is why probably people don't use them as much. So if we want to do that, stick to anonymous unions. Okay, so this is I guess, not as well known feature, generic selection. So this is again, sort of what is this, kind of a construct where, and again, in this case, you actually have to write it like that. There's no header file for it, where you pass it in an expression, and then based on the type of the expression, it will resolve to one of these. Right? So the example I picked here is, and this is a common thing in Postgres at least, is you have a lot of these bit manipulation functions, right? And often you have a 32-bit version and a 64-bit version. But if you think about it, there's nothing the compiler will check here that you're using the right one. If you use the 64-bit version and you pass in the 32-bit value, it will work fine, and the other way around as well. If you pass a 64-bit value to the 32-bit, it will truncate it, return it. There's nothing, it will not diagnose that at all, right? So in some sense, this whole API here is just held together by willpower. The way, so this is how you would do this better, right? Usually make this a macro, and then based on the actual type, it will call the right function. And if the type is not listed here, it will give you a compiler error. So this is a compile time thing. There's no runtime overhead or anything like that. So this could be quite helpful to do this more correctly. Another example where this is used, not necessarily for Postgres, but in sort of the other world where people care about floating point details a lot, you might have one for float, one for double, and then automatically pick the right one. Okay, so we talked about threads, so I'm just going to say it exists. We talked about it just now. I do support the idea of, making our little C11-like layer around it. For sort of my talk here, one thing to keep to note is there's a compiler and a library part, right? The compiler has the thread local storage classification. That's what the compiler does, and then all the other stuff is provided by a library. So in a Linux system, those could be two different things, right? Or it's usually the compiler is one thing and the library is another thing, and they might not necessarily support these things at the same time. And then the atomics was also just shown, so it goes really deep, right? The interesting thing to note perhaps is that before C11, C did not have any notion of concurrency at all. Right? That was just not in the standard. There was no discussion of memory ordering or what happens if a couple of things happen at the same time. There were signals, right? And there was a little bit of volatile that you could plaster in various places to hopefully make things work, but this was, very unsatisfactory. So now there's also, in C11, but also in C++, a memory model and just in general more support for doing concurrency at all. So even if you don't use any of this, at least you have sort of more support of doing concurrency at all. Okay, so now the question of how could we get our hands on all of this. So this is the compatibility chart that I put together based on some of my own testing and the information provided by various vendors and stuff. So these are the features that I suggest would possibly be useful for Postgres. And then you have GCC versions, Clang versions, Visual Studio versions. The cutoff at the moment, if we want to keep supporting RHEL 7, which is a debate someone else can have at some point, but at the moment, the minimum compiler we need to support is GCC 4.8. So with that, we could currently only use these top 3. So that's the green mark here. Generic selections, thread atomic types are not supported by GCC 4.8, so that will have to then wait or some. On the Visual Studio side, most of these features came in, as you can see, Visual Studio 19. Currently, Postgres supports back to Visual Studio 2015. I looked into the history of how we have decided to move that thing forward, and it was kind of interesting. When Visual Studio support was added in Postgres 8.3, the minimum version was 2005, which was just the latest at the time, and then we've never changed it for many years. And then in Postgres 12, we changed it to 2013, and the reason for that was actually to move to C99, so there's precedent for that. So if you do the math here a little bit, if so Postgres 12 requires 2013, Postgres 18 would require 2019, so that's the same. Obviously, Postgres 18 is not doing that, so if we were to change Postgres 19 to require Visual Studio 2019, that would be less restrictive than that move, right? So I think that's reasonable. All right, so this is a possible proposal. I'll bring that up at some point. Right, I think we could move to a restricted version of C11 for the next release. For non-Visual Studio use, this wouldn't really change anything at all in practice because all the compilers support that, have supported for a long time. For Visual Studio, we would move the version up, but I think that would also have benefits for other reasons because there's also other code we could clean up and various other benefits that I can't get into right now. And then as a separate step, possibly at the same time or later, depending on what we want to do with the threads project and those APIs as we had just discussed previously. And or we want to drop support for RHEL 7, and we can also require the full range of C11 features. So that is to be discussed at some point. So now C23. So there's quite a long list. So I'm going to go through some of them quickly, and I'll show some examples of some things that might have more sort of practical impact. So preprocessor stuff. These things, I think if you recognize them, will welcome them. the embed directive to embed a file. I'll show an example of that. There's a thing to check if an include file exists. So you can, again, sort of remove configure tests in certain cases, perhaps. Null PTR, that's a new keyword, which is a null pointer constant. And that is supposed to address the issue I mentioned at the beginning, that it's sort of ambiguous how to write a null pointer constant correctly. And so this is the, I guess, preferred way now. And you will see this in example code. So this might be a little surprising if you see, C23 example code or something like that. You'll see this everywhere. The type of, that has already existed as an extension for a while. That is standardized now. You can use type interference now, where you just, instead of a type, you just write auto, and then it figures it out. That can be good for writing generic macros. There's const expr, which is perhaps what people think const is, but const is not a constant, but this is a real constant. Binary littles like that, it seems pretty useful. You can have digit separators like that. In other programming languages, this would be with underscores, right? But because that already meant something different in C++, they settled on this syntax in both C and C++. So these things that I mentioned have this underscore business. That is not the case anymore. These are now real keywords in C23. Then there's a thing called empty initialization. So you can assign just empty braces to a variable that you're defining. Right now, in a lot of cases, you write brace 0 brace to do an empty struct initialization, which is almost the same thing. But this you can actually assign to any type. You can also use this for an integer. So this will work for any type. The attributes in double brackets I'll show. Functions without prototypes have been completely removed now. Integers are now required to be 2's complement. This was not required until now, but in POSIX this was already required. So again, this is sort of a thing that trickled down. There was a business with int max, right? Int max is supposed to be the largest integer supported by the implementation, but the problem was what if the implementation adds a 128-bit type at some point? Are you supposed to change int max? That will change the ABI. It was a big problem. The language has been, the standard language has been changed to clarify what you're supposed to do or what you're allowed to do. You can now have bit-precise integers, so if you want an integer with 23 bits, you can write it like that. You can have decimal floating point types, maybe not so interesting for us. And you can, if you have an enum, you can give it an underlying type specifically. This is something you could have done in C++ already. And some library stuff. Memset explicit is to sort of securely delete memory. That's something Postgres uses. There's a list of workarounds, so in the fullness of time, maybe that's something we could settle on. Some things have been moved down from POSIX. So the good old strutted up function is actually now a C standard function. And then there's some things that Postgres already uses in various custom ways. So integer operations with overflow check, and all these bit utility functions like pop count and stuff. There's like a library for that now. It's the same compiler intrinsics underneath. So maybe we could sort of decide to wiggle our way toward these standard names or not, or at least sort of align with that. Let's see. So the qualifier preserving standard library functions, I'll show an example of that. And then unreachable, for example, is also something that Postgres uses. That's standardized now. All right, let's show some examples. This is an example of how you use embed. One use for that, for example, if you want to embed an icon into your program, Postgres doesn't do that, but this is sort of a thing. We have this thing here, these DH parameters that are hard-coded somewhere in Postgres code. I don't know how they got there. I don't know if they're correct. Right? So this might be a nicer way to do that. Get this file, then you can checksum the file, you know where the file came from, and then you just embed it like that. Obviously, this is not something we're going to do now because we're not supporting that yet, but this is sort of the idea. The type of we're already using, this is actual code. This has been a compiler extension, so this, let's see, at the time, yeah, okay. The copy object copies nodes, right? because the nodes could have different types. The input type is void, output type is void. In order to make this a little safer, if the compiler supports type of, we're casting that back to the input type. So this is the actual code that exists in Postgres. So this has been around for a long time. It seems to work okay, but it's actually wrong. So consider this example code I made up. So this is the same stuff again. Here's sort of a node type, very simple, right? Just it has the type field and some data, right? And then this, I'm making something up here. This is so this transform function, right? Usually what you do is you get some value in, you make a copy, change some stuff around, return it. Pretty standard stuff, right? If you compile this, you get this warning this is from Clang, but GCC will give you something the same. Something discards qualifiers. So it's complaining that this construct here is returning actually a const qualified pointer, and you're assigning that to something that's not const qualified. And the reason for that is that, of course, the type of a const qualified pointer is also const qualified, so this will have a const qualified return type, which is exactly not what you wanted, because the whole point of this is to make a copy that you can modify, right? So this is like live code. I have no idea why we actually never run into this, but the way to fix that is to use the lesser known cousin of type of, which is also new, to use type of unqual. And then this is how you would write this correctly. So you have to do a little bit of a dance to dereference the type, take the type of that, and then make a pointer, and then it will work. So at some point, maybe we should change ours to do this correctly. Then the attributes, this is probably sort of the most noticeable syntax change if you just look at the example code. So GCC has this attribute syntax, right, that you can attach to all kinds of things to tell the compiler things, and then Visual Studio has decal spec, which sort of works similarly, and this is a standardized version of that. So here's the standard attributes, no return. This is the same as before, so this is actually sort of the better way of doing that. No discard warns if you don't check the return value. This is something Postgres code already does in other ways. You can deprecate things, maybe unused. These are all patterns that we're already using, right? And then these other ones here, fall through for annotating case statements and some optimizations. There's also a syntax for compiler extensions. So you're going to write clang, : or GNU, : and the important thing is that if the compiler doesn't recognize an attribute or doesn't support it or just doesn't want to support it, it just silently ignores it, which is good, because then you don't have to actually do configure checks for all of these. You can just write it, and it's supposed to ignore it if it doesn't recognize it. The flip side of that is that attributes cannot change program semantics. Right? These are all just annotations for compiler diagnostics or documentation, essentially, right? But the things I showed earlier, the align as specifically, that is under GCC an attribute, but under this system it can't be an attribute, which is why it's a different thing. It's its own thing, right? So that's also why you might ask, well, why didn't they just use this one? That seems widely used, but it was sort of a free-for-all, and there was also ambiguity about the placement. So the placement of these is now exactly specified, and it's also the semantics of what happens if you don't support it, and so on. So that's why a new syntax was chosen. And the same syntax also exists in C++, so you can actually also put these in header files, and it will work the same way in C and C++. So that's pretty nice. Okay, and so this is sort of a tricky one to wrap your head around, but this might be something that actually could affect us in practice. So I want to explain this. So this is as an example, there's a number of functions like that in the C library that take some string and do something with it, find a thing in it or something, and then return it. And the way you could use this if you're not careful is that you pass in a const qualified pointer, and then the return it's not enforced. This should be const qualified, but it's not enforced anywhere. And so you could lose the const qualification, and then essentially your program is sort of technically invalid, and you could do bad things. In C++, it's not a problem because these functions are overloaded. Right? There's two versions of this actually in the C++ library. One with const returns const, and one without const that doesn't return const. So that, and you want to get to the same. You want to do the same thing in C. How do you do it? Well, this is not like syntax, but this is basically the way the specification is written. It just says like it should work like that, and you figure out how to implement it. So this is in Postgres we would maybe call this a polymorphic function. It's like, well, if this is qualified, this should also be qualified, and if this is not, then it's not. So this is the way it's written in the standard and in sort of documentation websites, and then this will work, right? Because in this example case, the return type of this function is now actually const qualified, and then the compiler will enforce it. So this is a good improvement to make the type safety of the standard library better. This is an example of how you would implement that. And you use this generic, right? That's sort of a trick to do overloading, essentially. And so you could implement it like that. This is not quite how you would actually do it, because it doesn't handle certain edge cases correctly, null pointers and stuff like that, but this is sort of an idea of how you would do that. This is a list of functions affected by this. So you can see there's some memory. So these are void pointers, memory functions, but also some string functions. I looked through the Postgres code sort of in a kind of manual way. There is at least one case where if a library were to do that, we would get a warning. So there is potentially something to fix if this ever gets activated by actual implementations. So yeah, so in terms of actual implementation support, GCC 14, which came out last year, has pretty good support. They don't actually claim it's quite complete, but I did most of the exploration testing with that, so that's good. It's pretty good. In GCC 15, which came out just a few weeks ago, it's claimed to be complete essentially, and it's also turned on by default. So if you just use, this is already in certain Linux distributions, so it'll hit you, right? Clang 18 is from last year, also has support, so it's kind of common, or it's in the compilers. The libraries are, again, like I mentioned with POSIX, they're going slower. But a lot of these things already exist as extensions, so you can sort of opt in. So this is this is my plan here to, some of these we could adopt, some attributes, type of stuff I explained, and then according to my calculation in Postgres 30, we could make that the default. Okay, so yeah. C99 in POSIX 2008's current baseline, maybe move to C11, I'll propose that. Some new stuff. All the information is public again. You can just look it up. And we have 1 minute. I'll show you a couple of extra things that are in the next C standard draft right now. So just look into the far future. This is already in the draft to change the octal literals to be less confusing. This is in there to break out of an inner loop. That seems useful. So in shell, you write like break two. So you would essentially use a label to break out of a loop. So that's in there. And what else do we have? Declarations in the if condition. So this works a little bit like the for loop, right? In for loop, you can do this. The change here, so you can also do it in if statement. This looks maybe like you might ask yourself at first, it seems useless, but I think can actually be quite interesting for certain programming patterns. Case ranges has been a GCC extension for forever, but now it's in the draft. And this one is not in the draft yet, but this is actually seriously being worked on. This could be a quite big change to see, to have this defer clause to register cleanup handlers. In this, obvious cases for malloc, but this could also be for file handles and all kinds of things. So this is seriously being worked on, in Outlook. So that's all I have. Thank you very much.